Hello everyone, welcome to Engineering Archives. Let us look at practice problem number 2 for this chapter, force vectors. This question says, determine the length of member AB of the truss by first establishing a Cartesian position vector from A to B, then determine its magnitude. So we can see that in this problem they have given us a two-dimensional system of trusses, and we are supposed to find the length of this truss A to B. Now they want us to find the length by basically they have given us the procedure, the way to do it, and that is they want us to first find the Cartesian form of this vector from A to B. They want us to find the Cartesian form, and after we have done that they want us to find its magnitude. So we can find the Cartesian vector for this vector, this length vector from A to B, by finding the length components along the x and y direction. So if you look at the y-axis, we can see that we can easily find the y component of length for this length vector AB by simply subtracting 1.2 from 1.5. So if we subtract 1.2 from 1.5, we will get this remaining length, which is the y component of the length vector AB. And so we can easily see that the y component of length for this vector is 0.3 in the positive direction, so it's going to be 0.3j. Now to find the length component in the x direction, we will need to use some trigonometric identities. So we can see that they have given us the length from this point to this point, which is 0.3, but we still need the length from this point to the point B. So to find this length, we can use this right angle triangle right here. So we can use this right angle triangle right here. Okay. So let's find this length. So first of all, we can find this diagonal length, this hypotenuse length right here, by using the identity sine of 40 degrees x multiplied by sine of 40 degrees, while this length is x, right? This hypotenuse length, this is x. So this length x multiplied by sine of 40 degrees should give us 1.5. So I simply applied the sine identity on this triangle, and by applying that I got x sine of 40 degrees is equal to 1.5. Okay, so now solving for x, we get x should be equal to 1.5 divided by sine of 40 degrees. I'm not gonna solve this on a calculator, but I'm just gonna use this value for x until we get the final value for this unknown length. Okay, so now that we have our hypotenuse, we can simply use the cos identity to find this unknown length, and we can do that by simply doing x cos of 40 degrees should be equal to the unknown length that we are looking for. In other words, the unknown length that we are looking for is equal to x, which is 1.5 divided by sine 40 degrees multiplied by cos of 40. Okay, so this unknown length would be equal to 2 point no, this would be equal to, let me solve this on a calculator. 2.09. So 1.79. Okay, so once we have this unknown length, we can find the total y component for the vector AB by adding 0.3 to 1.79. And once we do that, we get 2.09 meters. So now we know that our x component for this length vector is 2.09 I. Okay, so this is the Cartesian form of our length vector AB. Now that we have this Cartesian form, we can just find the magnitude by using the magnitude formula. Okay, sum of the squares of each component, and we simply get 2.95 to three significant figures meters, and this is the length of our vector AB. So this was the easy procedure for this question. Thank you very much. See you in the next video.